Good afternoon, Good afternoon, everyone. My name is Krishna Madhuri. Today we'll discuss about linear list in data structure. What is a linear list? Linear is a sequential manner. By the name itself, we are saying that it is in sequential manner. A linear data structure has data elements connected to each other so that elements are arranged in a sequential manner and each element is connected to the in front of it and also behind it. This is the way the structure can be traversed in a single run. In linear data structures can be implemented easily as computer memory is also linear data structures. Now we'll see types of linked list, types of linear list. There are 4 types of linear list we have: arrays, linked list, tags, and also queues. Now we'll see about arrays. What is an array? Array is a collection of same data type that is stored continuous memory location. That means if we are storing an integer type of data, we'll store integer type of data only, and also it has a static memory allocation. That means we need to give the size of the memory before we are entering data. So if an array of 10, if we are giving the 10 elements, without 10 other than 10 elements, we cannot insert 11th element also. So that is the reason arrays, that is the drawback of an array. So they introduce linked list also. So what is a linked list? Linked list is a data structure, linear data structure in which elements are linked using pointers. It consists of 2 nodes. Actually, linked list means it stores the elements in the form of nodes. Every node consists of 2 fields. Each node consists of 2 fields. That means data field as well as address field. Whereas data field stores the memory, that means whereas data field stores the data, that means element, and address field stores the address. Address field stores the address of which element? Next element, address of next element. That means after reading the data, we need to go for the next field, that means address field. So after reading that element, that address also, so we need to go that by addressing this. So next element and next address field. So like that, we'll read all the elements in the field, and it has a dynamic memory allocation. It is not a static memory allocation. We can insert number of elements. What we are inserting, number of elements we are inserting, and this is a dynamic memory allocation. And next, what is the last field? Last field contains null. That means while seeing the null, it shows the end of the list. Got it? This is a node representation. This is a node, and this is a node data field. This is the address field. Address field storing the address of next element, that is 20th address, where 20th memory is located. That address is storing here only. And last node which is containing null. This cross mark indicates null. Okay. And next we'll see about algorithm. How the pseudocode will be here. Start in front of this. First, we need to read first element. That means friend. While there are more nodes to print the current node of data. And also go to the next node. That means we are printing 10 here, and we are moving to next field. And here we are reading the address. What we are doing? We are reading the address. So by using that address, we need to go the next element, and we are reading this also. And next element, and also we are reading next element. So like that, we are reading this element and next element. This is indicates, this shows null. While we are indicating null, cross mark indicates null. Okay. Next, how many types of linked list we have? We'll see. There are 3 types of linked list we have: single linked list, double linked list, as well as circular linked list. In single linked list, the data field and address field is there, as like linked list we are discussed just now. And also in double linked list, it stores the address of the first element as well as next element. In circular linked list, we have 2 types of circular linked list. What are they? Circular using single linked list as well as circular using double linked list. Circular using single linked list means circular with single. Circular linked list means in the single linked list, last node indicates null. But in circular single linked list, last node stores the address of the first node. Got it? And circular doubly linked list means last node stores the address of the first field as well as first node before field stores the address of the last field. Okay. Now we'll see deep about single linked list. This is a single linked list. Single linked list is a sequence of elements in which every element has linked to the next element in the sequence. So every individual element called node, that means every individual element called node. Each node consists of how many fields? 2 fields, which is data field as well as address field. The first node is called header. The first node we need to indicate that header field, and it points to the first node of the list and helps to access the every other elements in the list. So the data field is used to store actual value, the node, and next field is used to store the address of the next in the sequence. Got it? In single linked list. In single linked list, navigation only forward direction. That means we are going to move forwards only. We are not moving to backward direction. And what is the first node we need to indicate? The first node indicates header field and last node indicates data field. And also last node of last node of address field consists of null. Null indicates end of the data, end of the elements list, and single linked list end. Okay, now we'll see about how the representation will be. This is a single linked list representation. This is the basic structure. Basic structure of single linked list is struct node, whereas we are giving data field as well as address field. So data field is a type of integer. Address field is a type of struct node. As you already everyone knows in C, structure field consists of struct node data. This is a basic structure about this linked list representation. For every linked list representation, this is the basic structure we need to remember. Struct node star head is equals to null. By default, every header is equals to null only. And this is a linked list representation. This is the first field, that means address. This is the data field as well as this is the next field. And this is the data field and this is the next field. So we are storing the last null. But here we are storing the address of the next field. So for creating, we have 3 types of creations. We have 3 types of creations in single linked list, 3 types of deletions in single linked list as well as display function. Now we'll see how the data will be, how the structure will be created in the form of pseudocode. So first we need to allocate a memory. That means this is the basic structure of memory allocation. And new is equals struct node star malloc. This malloc function is used to allocate a memory in a computer memory, in a system, CPU. And malloc of size of struct node. Got it, ma? And by the name itself, by the reading this line in the C language, there will be a memory allocation will be done for new. So in that memory allocation, first field consists of data. So that field we are reading the value. From scanf, we are reading the value. We are storing the value where new node of data field. Next, again, new of next field, we are storing the null. As we are creating only one node is present is right. So we are creating only. If head is equals to null, if we are inserting the first node, then head is equals to new as well as temp is equals to null. We are receiving temp. We are also using temp. By the temp itself, we are using temp is a temporary memory location. So we are using that temp for traversing data. Okay, else temp of next is equals to new as well as temp of next is equals to temp. That means we are allocating a memory. New allocation will be done temp of next. And next we are moving the temp to the first field. Got it? Next, we'll see about display field. In display field, we need to allocate a temp is equals to header. That means header and temp at the same position only. While temp is not is equals to null, that means if there is any element is present in that, then will they execute this. So printf percentile d comma temp tends to data. That means we are reading that, we are showing that element. We are showing that element. And next, we are moving to the next field. So again, the data, if temp is not is equals to null, again, so like that, every element should be displayed. Got it? Now, insertion at begin. As I said, insertion methods are insertion at begin, insertion at end, insertion at a particular position we'll see. But insertion at begin, first we'll see. First we are inserting a node as a first node. If there is a element presented in the list also, we are inserting a node as first. That means we are allocating a memory first. First, we need to allocate a memory. Next, we need to read that value as well as new of data is equals to value. Next, new of next is equals to what should we write? Header, because we are inserting a element as a head node. So that is the reason what is a header represented in that list. It should be, that address should be stored in new element. So that is the reason we are writing head here. Got it? And next we are moving head to the new field. So new field, first we should move head field. So that is the reason head is equals to new. So now head and new are in same position. Now we'll see insertion at end position. If temp is equals to, initially temp is equals to head. Insertion at end means we need to move at last one. So that is the reason we are reading. First we are allocating a memory as well as we are moving end position. How should we relate that end position? End node is if that address field contains null. So by using that condition, while temp of next is not is equals to null,